Hello students, I am Professor Godge from ERTC department. So in today's session, we are going to discuss about our unit number 1 of the subject EMI, that is the fundamentals of electronic measurement. So let's start our discussion. So these are the points of discussion. First is measurement, second is characteristic of measurement. So under that, two characteristics come, static and dynamic characteristic. And the last point is classification of instrument. That is how the instruments are classified. So the instruments are classified into two types: secondary instrument and absolute instrument. So the first is what is measurement. तर मेजरमेंट करतो आपण म्हणजे काय करतो की कुठल्याही गोष्टीचा आपण मोजमाप करतो. ओके, सो द डेफिनेशन फॉर मेजरमेंट इज it is the assignment of a number to a characteristic of an object or an event which can be compared with other objects or events. Means the assignment of a number to a characteristic of an object or an event means some values we assign to some objects and then it can be compared with the other objects or events. Then next is static characteristic. So the static characteristics are also classified in many types. So the first characteristic come under the static characteristic is accuracy. So when we say the device is accurate, when its reading approaches the true value of a quantity which being measured, means there is some standard quantity and the device is quantity which we have to be measured. If these quantities reading are very close to the standard quantity readings, then we can say that it is very accurate device. So this is nothing but the accuracy. Next is precision. So the precision means it is the measure of the reproducibility of a measurement. Means whenever we take the measurements of any device and it again and again reproduce, then we can say that the device is precise. Next type is static error. So what is the error? The error in the instrumentation system means it's the difference between the true value and the measured value of a quantity. Means there are some true or a standard values and some values which we measured. So if there is a very big difference between this standard value and measured value, then we can say that there is an error. So this is called as static error. Next is repeatability. So its name itself indicates the measured value, it comes again and again. So the definition is it is the measure of closeness with which a given input may be measured over again and again. Means whatever there is input, this input can be measured again and again. This is called as repeatability. Next one is reproducibility. So what is reproducibility? Its definition is it is the degree of closeness with which a given value may be repeatedly measured. Means if there is some value and this value can be measured repeatedly. Means whenever we take the measurements, we again and again measure the same value. So this is called as a reproducibility. Next is linearity. The definition for linearity is if the output of any device is proportional to the input, then it is called as a linearity. Proportional to input means if your output is varies according to your input. Means you change the value of input, according to that the output of the value of output is also changes. Means there is a proportionality between output with respect to input. So this is called as a linearity. And last one is sensitivity. The sensitivity means it is the smallest change in the value of a measured variable to which an instrument responds. Or also we can say the sensitivity means their change in output with respect to change in input. So this is the another definition of sensitivity. The next characteristic is dynamic characteristic. So under that, the 4 points come. First is speed of response. So what is speed of response? Its name itself indicates how much it responds with its speed. Its definition is, it is the rapidity with which the instrument responds to the change in measured quantity. Means if there is some change in measured quantity, then at how much speed your instrument responds to this change. So this is nothing but a speed of response. Next is fidelity. The definition for fidelity is, it is the degree with which the instrument indicates the change in measured value without any dynamic error. Means without any consideration of a dynamic error, if there is any change in measured value, it can immediately indicate. This is the fidelity. Then lag. So what is lag? It is the delay in the response of an instrument to make the changes in measured quantity. Means whatever the quantity you measured and your instrument delays to respond with the change in measured quantity. So this delay is considered as a lag. Then next is dynamic error. So dynamic error is also similar to the static error, but the main difference between these two errors is, here is no static error is assumed. Means there is a difference between true value of a quantity with time and the value indicated by the instrument with no static error is assumed. This is a dynamic error. Next is the classification of instrument. Our instrument is classified in two types. First is secondary type and second is absolute type. So secondary is also classified in three types. First is indicating type, second is recording, and last one is integrating. So let's see one by one. First is indicating type of instrument. So the meaning is in its name. The indicating instrument means it indicates the magnitude of a quantity to be measured. Means whatever the quantity we measured, it indicates the magnitude of that quantity. And the indication is generally in the form of a scale and pointer arrangement. For example, ammeter and voltmeter. So these are the indicating devices. So the quantity includes the readings which we have to be measured. We just simply connect the ammeter and voltmeter across it, and whatever the readings of that device, it display on the ammeter and voltmeter. So for the display purpose, there is a pointer or scale arrangement in this voltmeter and ammeter. So the pointer varies and it indicates or displays the reading of that particular device. The next one is recording instrument. So what is a recording instrument? Some process require a continuous record of a measured quantity. For example, ECG. So in medical applications like ECG, where we require a continuous recording of this quantity. So in that application, we use the recording instruments. Second example is earthquake monitoring system. So there is also we require a continuous record of the earthquake. So in that application also we use the recording instrument. And the last type of classification of instrument is integrating type of instrument. The simply integrating instrument considered as it is the integration of quantity under measurement over a period of time means whatever the quantity we have to be measured, it integrate that quantity over a period of time. So these are the classification of instruments. Okay. Thank you.